Hey everyone, welcome back. Today we're doing TwoSums together, one of the questions in the Blind 75 series. For the new viewers who are not aware of the Blind 75 series, that is a curated list of questions by a Facebook tech lead based in Singapore. And this Blind 75 series is meant to cover most of the problem spaces and concepts that you would need in a technical interview. Typically, technical interviews would give you a puzzle question, for example, what you see over here. And you'll be given a question together with the input and expected outputs. And we're expected to come up with an algorithm to solve that question. For today, we're given an array of integers numbers and an integer target. And we have to return the indices of two numbers such that they add up to the target. So for example, in this case, this is the array of integers that we're given, and this is the target. And we can see from a quick glance over here, the two numbers in the first and the second position, index 0 and index 1, will give us the target of 9. So because that is the case, we will return the corresponding indexes of 2 and 7, 0 and 1 in a list and give it back to Leetcode. So in this case, the answer can come in any order. So this makes our life much easier. So in this case, we can assume that each input would have exactly one solution, and you may not use the same element twice. And just a little note, notice that in the second example test case, notice that the numbers in the list is not guaranteed to be sorted. And it is also possible for you to have the same number inside the numbers over here. So in this case, the length of the list is from 2 to 10 to the power of 4 in terms of numbers, and each number will range from negative numbers to positive numbers, and the target can also be a negative number to a positive number as well. And finally, Leetcode is also asking us if we can implement an algorithm that is less than quadratic time complexity. So this means if ideal, it's possible that if n is the size of our list, then it would be nice if we can come up with an algorithm that can scale hopefully linearly, like at least linearly or in less time complexity compared to O(n) squared. So with that, let's get started. One approach that we can do, if I bring up the notes over here and show you this, one method that we can do is to keep track of a cache of dictionaries. So this dictionary over here would keep track of, for each corresponding number that we have seen in the past, give back the index for that corresponding number. And the idea is, if we iterate through the list from left to right, we can, at each step, get the corresponding complement that we need to get the target. So for example, if you're currently starting at the start of the list and the current index is equals to 0 and the current number is equals to 3, then the target that we're looking for in this case is 3. So we can check in this cache to see whether if we have seen 3 before. And if that's the case, then we can return back the current index together with that corresponding index inside this cache. So I will iterate through this algorithm using this simple test case 3, 2, and 4. So currently we are starting off with index 0. The current number is equals to 3. And the corresponding complement that we're looking for, in this case, would be target minus 3. So in this case, this is really 6 minus 3 equals to 3. So we check our current numbers to index cache for whether if 3 exists. And because we just started, understandably, the cache will be empty, so we understandably do not find the complement. So we continue the search. But before we continue to the next index, we would add the current numbers together with its corresponding index inside this cache. So that subsequently, if we go to the right and we find another 3, then we can return this current index together with that index. So we put that in and we continue. So current index is set to 1, current numbers is set to 2. So we continue, and currently the complement is target minus 2. So this gives us 4. And we check if the numbers to index cache have 4. There's no 4. So in this case, we skip this as well. So we would add this corresponding number together with the index into the cache, and we continue. So now we're at index 2, and the current number is 4. So the complement is 2 because 6 minus 4 will be 2. And now we check our nums to index cache and we see that, oh, okay, there is a 2 inside this cache. So what we can do is return the current index, which is current index together with the corresponding nums to index cache for this given complement. So this expression would give us 1 and 2. So this would give us back the answer over here. So actually I made a mistake over here. Current index should be 2 and nums to index cache complement should be 1. So, but this is pretty much a algorithm that allows you to solve this in O(n) time complexity. So this is way better compared to a quadratic time complexity solution. So with that, let's get started with implementing this. So similarly, let's define the nums to index cache. This would be of type dictionary of an integer to an integer. Just define it as an integer, as a dictionary like this. And the next thing that we will do is do a linear scan across numbers and proceed to populate nums to index cache. So for index and number in enumerate nums, this expression will give you back a tuple of index together with the corresponding number in this list. So we will calculate the complement. The complement is equals to target minus number, and we will check if complement is inside this nums to index cache. So if the complement is in numbers to index cache, it means that we have found our pair. So we can return the current index together with nums to index cache for this given complement. So we are returning back the index of this complement that we found. Else, then we would proceed to populate this current nums to index cache for this given number and set it to index. So hopefully in the subsequent iterations, as we iterate the list from left to right, we can hopefully find the corresponding number, and the corresponding number will be able to find this current index to return back a pair. So that's pretty much it for this solution. Let's run this. This is accepted. Let's run this. And that's pretty much it for this solution. For completeness, I'll also be going through the time and space complexity of this solution. In this case, the time complexity is O(n) because in the worst case, you have to iterate through the entire list to get a pair that corresponds to the target. And the space complexity in this case is O(n) as well, because we use this cache to keep track of all the previous numbers that we have seen together with the corresponding indexes. So the space that is used in this cache will also scale linearly together with the size of numbers passed into this function. So with that, that's pretty much it for this practice. If you find this useful, please give us a like and subscribe, and we will see you in the next video.